Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have to find the minimum distance from this line x plus y equals 6 to the origin. Now, that means we have to minimize the distance formula and subject to this constraint. But in the book, there's a hint that we should minimize the square of the distance function. So let's do that. Let's minimize not d but d square, and d square is given to be x square plus y square. And that makes sense because what is the distance of any point, say x comma y, from the origin is the square root of x square plus y square. So the square of the distance is just x square plus y square. And we have the constraint that the point has to be on this line. So this is our constraint that x plus y should be equal to 6. Now we will be using Lagrange multiplier to find the minimum value, which means we have to define a new function. So let's do that. Let's define our new function, call it f, and the variables are x, y, and lambda, which is the Lagrange multiplier. And how is f defined? It's the function d square, so x square plus y square, minus lambda times another function that comes from the constraint. So we can rewrite this as x plus y negative 6 is equal to 0. So we take x plus y minus 6 as our another function, the function g, and we put it right here. Okay, so this is the definition of the new function, big F. And let's rewrite this one more time by distributing the negative lambda. So negative lambda x, negative lambda y, plus 6 lambda. And now we have to take the partial derivatives of this f with respect to x, y, and lambda, set them equal to 0, and find our critical number. So let's do that. Let's compute fx. Remember, partial with respect to x means y and lambda, they are both constants. Okay, so the first term, we have 2x, then we have 0, then negative lambda times 1, and then 0 and 0, because they're all constants with respect to x. Okay, compute fy. First term will be 0, second term, derivative is 2y, then 0, then negative lambda, and 0. Finally, f lambda, so first two terms, derivatives are going to be 0. Then we have negative x, negative y, plus 6, because derivative of lambda is 1. Okay. Now we set each of these equal to 0 and try to find the value of x and y. So let's see. From the first one we will get lambda is equal to 2x. From the second one we have lambda is equal to 2y. And then together these two will give us 2x is equal to 2y, because they're both equal to lambda. But then that means x should be equal to y. You can cancel out the 2, right? So we take x equals y and plug it in the last equation and see what we have. So here we have negative x, negative y, but instead of y we're writing x plus 6 is 0. So negative 2x plus 6 is 0, which means 2x is equal to 6. So x is equal to 6 over 2, which is 3. And since y and x, they have the same value, this is also the value for y. So we get our critical number to be, so critical number is 3, 3. Now we should check quickly if this will give us a minimum or not. So you can do a second partial test if you want. Okay, so remember we have to compute the second partial derivatives, fxx, which is the derivative of this expression with respect to x, so that is just 2. Then we have to compute fyy, and we will have 2 again, and then fxy. Fxy is take fx and take its derivative with respect to y, and that will just be 0. And then this d function is the one that will determine whether it's a minimum or maximum. The formula is fxx fyy minus fxy square. So this is 2 times 2 minus 0, which is 4, which means d is positive, and if xx is positive, that means it's a minimum at the critical number 3, 3. So this checks that we will get minimum distance using this particular critical number. And now we have to find the minimum distance, remember? Okay, so keep in mind that's not this function, that's the square root of this function. So what is our minimum distance? That's square root of x square plus y square, which is square root of 3 square plus 3 square, that's 9 plus 9, that's 18. So the minimum distance is square root of 18 units. So this completes the problem, but just think about it for a second. We needed to minimize distance d, but we minimized the square of it, d square. How does it guarantee that d square and d will have the same critical number? Because we found the critical number for d square, right? Just convince yourself that that is the case, especially because the function d is a positive function. You see that the output will never be negative, right? So just think about it. How do we compute critical number? We take the derivative of the function, right? So you can just sit down and write it down. What is the derivative of d and what's the derivative of d square going to be? And then you will see that when you set them equal to each other to find critical number, you will get the same value always. Again, because d is positive. So that's why finding minimum value for d square is same as finding minimum value for d. So that completes our problem. Thank you.